Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Episode 27, String Theory. So now is finally the time where we will talk about string theory. So I think in the English podcast this is nothing so special because I did not tease it as much on the German as on the German podcast and did not follow through until now. But still, I think it's a big deal to now be talking about string theory. I think on the English podcast there was not as much background as you might have noticed in the episode about the Higgs mechanism, that there was a lot of background I needed to cover still. I hope this will not be as much the case in this episode, because I also am basing it on an introduction of somebody who also did this for people who have not that much background in particle physics and so on. But if it's needed, I really will dive deeper into the background for you to really understand what this theory is all about. So let's begin. At first, we need to answer, okay, what actually is string theory? What do we mean by that? What does it say? And if you just ask people around or type in Google what is string theory, you will hear different things, and one of these things might be it's a theory about quantum gravity. So quantum gravity is something that is often used to describe what string theory is, or also more generally a theory of everything. So a theory of all the things, of everything, whatever, or word, yeah. So Let's go with the latter. So theory of everything. So what is everything? What do we mean by that? Okay, everything is this whole universe. So basically planets, stars, water, people, animals, trees. Okay, so then let's just start with people. What are people or humans made of? Humans are made to the most part of water. So, okay, what is water made of? Water is made of 2 hydrogen and 1 oxygen atom. Okay, atoms. What are atoms made of? Atoms are made of a nucleus and an atomic shell. And this nucleus consists of protons and neutrons. And then those protons consist of quarks. So quarks, what are those? Those are particles. Those are point-like particles, you say. So they are in our current theories, they are the fundamental building blocks of matter. Okay, matter particles, foundational or fundamental building blocks of matter. So that's where we are. But this is not everything. We have these matter particles. There are also not only the quarks, as we saw in the episode about the Higgs mechanism. Also, there are not only the quarks, but also electrons and electron-like particles. So before, when we were talking about atoms, we were immediately going to the nucleus. But I also mentioned there's also an atomic shell, and in this shell there are electrons. So those are also matter particles. But those are not all the particles. There are also forces. So, for example, electromagnetism is a force, or the strong nuclear force which holds together the nuclei, or the weak nuclear force which is responsible for radioactive beta decay, for example. And those as we also heard in the episode about the Higgs mechanism, those are produced by exchange particles, and those particles are, for example, photons for electromagnetism, or gluons for the strong nuclear force. And with all this, if you all put this together, and of course also with the Higgs that we heard about 2 episodes ago, then what we achieve is the so-called standard model, where we have all these particles in there that all together describe almost everything that we experience around us. I said almost everything, because if you thought along which force I might have missed, then you would have understand, okay, something is missing, and that's gravity. Gravity is not part of the standard model and is not described by it. And this is kind of odd, because it's something we experience every day. It's the first thing, or maybe the first forces that we experience in our life where we really understand it as a force. So why is it that this is not at all included in this standard model of particle physics, in the standard model of the universe that we currently have? And the reason for that is that gravity is different than all the other forces. Because for once, it results from the curvature of space, which is different than the other forces being mediated by some kind of particles, or even if you look at them not on a particle level but on the classical limits, it's still very different that gravity results from the curvature of space, from a property of space itself, and that this is responsible for gravity to occur. And another thing that is really different about gravity is that it works on everything, that it influences everything. So everything is affected by gravity. So if you just know Newtonian gravity, you might say, no, that's not true, because it only works on matter, on things that really has mass, that has a weight, that has mass. But if you look into general relativity, which is the description of the current description of gravity that we have, you will see that this is not true. That it does even work even affect light. So even light is affected by this curvature of space and therefore by gravity. So nothing can get away of gravity. Everything is gravitational interacting, and this is not the case for the other forces. For the other forces, they all have a charge. So they have the particles participating in this force have a charge, and by this force is mediated. For example, in electromagnetism, you have the electrical charge, and particles or objects that do carry electrical charge take part in this electromagnetic interactions. The same is, of course, true for the strong nuclear force and also the weak nuclear force. However, for gravity, this is not the case. For gravity, everything is affected. And this leads to a problem, because then gravity, or a graviton, if you would postulate it, would gravitatively interact with itself, and this in such a way that the closer you look into it, the more you see things that a graviton will interact with, and therefore at the place where the graviton is, there would be so much energy, so much interaction, that it basically would become a black hole, as we learned in one of the last episodes, where we talked about the problem that quantum gravity has, or that the problem that one has when one tries to come to a theory of quantum gravity. So the question is, how can we solve that? How can we resolve that? Do we get away of this contradiction? And the idea is that what we see as a particle is not actually a point-like object as in our particle theories, but actually it is something it is a closed string. So it is like a string, and this is closed, and this is the basic idea of string theory. So we basically avoid this by saying you cannot go ever closer to this graviton, and therefore always more and more increase the energy, because at some point it won't be you won't get closer, it will just be this closed string, and not a point-like object where you can get closer and closer and closer to it ad infinitum. So, before we continue, let's have a short break. And I thought in these breaks, I will shortly give you just some insight into my new novel, Alien Thoughts. So, if you not have read it yet and you are still trying to think about, do you want to get it, do you want to read it, is it something for you, then I think with these short extracts you will get just some idea whether this book is something for you. So let's start. The Planetary Protection Headquarters was already bustling with activity. Patricia walked quickly to her office. Even though most of her work was done by artificial intelligence machines, there were still enough tasks that required the skills of a human. In addition to maintaining the machines, developing new and better algorithms for the AIs, and finding solutions to processes the huge and ever-growing flood of data, a lot of monitoring activities had to be conducted. The AIs were good at maintaining control without human help, but every now and then problems arose that they were not equipped to handle. That was the job of people like Patricia who worked in this area. Every day she sifted through the logs of what was happening and what the AIs had no answer for. In the best case, a generic solution was found, which was then implemented in the AIs, further improving them. Patricia focused mainly on monitoring the American territories, also known as rebel territories. When Gerald King tried to prevent the NCD 2000 from going to the market, failed and was fired from his company, he founded a movement to politically oppose the introduction of the chip. He set up an office in New York City and tried to achieve independence from the chip technology. This went under the name Negotiations of Independence, or NOI for short. His efforts were in vain, but he found enough supporters who formed a community in Arkansas and resisted the coercion of implanting the NCD 2000. When government pressure became too much, they went into hiding. Since then, nothing has been heard from Gerald King and his followers. But in the years that follows, there were rebel groups in the American provinces. It is suspected that Gerald King led them from the underground. The rebels were familiar with the chip's technology and knew how to minimize its influence. Over time, the rebel movement grew. Eventually, it succeeded in overthrowing the administration of the American province and established a rebel government in its place. Spurred on by this success, they declared war on the New World government under Boris I. A big mistake, as it was soon to prove. In the course of the conflict, many former major cities, such as New York and San Francisco, were completely destroyed. People fled to the countryside began a primitive life as farmers. Many believe that Gerald King died in this war, as he is believed to have been in New York City during its destruction. Boris offered all who submitted to the terms of the planetary government a life of prosperity and left the American provinces to the defeated rebels. These continue to live in pre-industrial conditions to this day, and nothing seemed to change this fact. That's just a short extract. It's about at the beginning of the book when the plot starts to move and it starts to begin. And if you want to find out more, if you are interested in how it will continue, what will happen, what this is really all about, then I really encourage you to get it and to read it. So you can just go to Amazon, type in Alien Thoughts and my name, and then you should surely find it. And if you have already read it, then I really hope that you give a review and this way help other readers to get aware of this product and to know if this would be something for them, and encourage them to get it as well. So thank you for your support. So this is the basic idea of string theory, and hence also, of course, the name string theory, because it's a theory that postulates that the fundamental building blocks of matter are strings. So now if you know from music theory, basically, that if you, for example, have seen a guitar, that if you have a string and it can swing, it can have it can oscillate and so on, and it can oscillate in different modes. And in string theory, you say that all these different modes in which this closed string can oscillate, all these are different kinds of particles. So, for example, if it vibrates in this one mode, then it would be a quark. If it vibrates in this other mode, then it would be a photon, and in again another mode, then you would have this graviton, and so on. So this is really satisfying, because instead of a kind of a zoo of particles, as you have in a standard model where you have families of particles and and so on, and many particles, in this case you really just have one closed string which is vibrating in different ways, and this all leads to the different particles we see. So with this one closed string, you can basically reproduce all the many different particles that we see in the standard model. So you have really simplified this whole standard model just to one closed string. So, however, it's not that perfect, because you also get some problems. And the greatest problem I think you get into is that this theory is mathematically only valid or only workable if you have 10 dimensions, if you are working in 10 dimensions. However, if you look in the world around us, you will quickly realize that we only have 3 spatial dimensions and 1 dimension of time. So we only have 4 dimensions. So 6 dimensions, where are they? Where are the other 6 dimensions? And instead of dropping this theory, then what one does is one says, okay, the other dimensions, they are just rolled up. And to understand this, you have to think of, for example, if you think of a 2-dimensional plane, and you like a sheet of paper or something, and if you have like an ant or some small animal walking around it, it can of course go into these 2 dimensions. It can go horizontally or vertically along this plane, along this sheet of paper. However, if you now start to say, okay, I will roll this sheet of paper up really, really tight, really closely, then for the ant, if it's close enough, at some point, the ant will only be able to walk in one direction of it, because it's in the other, it's so rolled up so tightly that it basically cannot walk into that direction anymore. And for the ant, it will in the end be basically a one-dimensional object. Another way to illustrate this would be to think of if you have a metal, a plane of metal, and you roll this up like a pipe, for example, and you do a really narrow pipe, and then you walk over it, like you try to walk over it, and then for you it will also be one-dimensional. You will only walk in one direction, because in the other it's just too thin to really be something where you could walk along, and therefore it would be, although it is a 2-dimensional object in the beginning, it would occur to you like a one-dimensional object. And in string theory, you basically make the same assumption that all these 6 dimensions, they are rolled up such that they are not visible to us, that we cannot see them, that we cannot experience them, although they are there. And this is pretty complicated mathematics, with which you can achieve that. And in the end, you will have a result, or it will result in a world as we see it, and you have this problem of the graviton resolved. However, with all this, the question is it true? Is nature really in that way? Are there 10 spatial dimensions and the ones we do not see are just rolled up? Or is there a different theory describing all this? And the thing to know if it's really true, of course, we have to make an experiment and see if it is true. The problem with that is that those strings are really, 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 really small. So they are at the Planck length, and the Planck length is about 10 to the minus 35 meters. And it's to show you how small this is, if you would take one atom and increase it in size so far that this one atom would be as big as our universe, then this string that we are talking about would be about 1 meter. So it's really small. Even on the scale of for an atom, it would be just even small. So it's basically impossible to resolve this to really find to confirm directly the existence of strings, and therefore we need to confirm it indirectly. So, and this so far has not worked, or is not really promising, because the prediction that these indirect prediction that string theory would make are really hard to prove, or there are not many of them, and those that there are really hard to prove. They require really high energy experiments, which so far we do not have in some cases. So it's really hard to prove whether this is actually the case. And also, I think as beautiful as the simplification of describing all the particles by one string which is vibrating in different modes, as beautiful that is, as ugly to some degree is this complication with all these additional spatial dimensions and so on. Therefore, I'm still not really convinced that this theory is showing the truth. Also, it really is the ugly part of the theory really is also that it is kind of hard or impossible to prove, not only because of the difficulty in resolving such strings, or the impossibility of resolving such strings, but also because there are really few predictions this theory makes. And the theory, as many say, is always only just as good as the prediction that it makes. And if a theory does not make many predictions that really can actually be confirmed in doable experiments, then this theory is all really of less value than a theory that does. So therefore, I'm still very skeptical about string theory. Also, it has some charm to it, of course. And what I think is especially fascinating on this is it shows the fact that gravity is really affecting everything, is working everywhere, and I think this is can also be considered as an image of God, that He's really affecting everything, that He's working on everything, and that He really pulls us to Him, or wants to pull us to Him. And if we yield to Him, He will do that, and He will pull us to Him, and He will really change everything about us, because just as gravity affects just everything, God will affect everything of us and also change everything of us if we yield to Him, if we give ourselves to Him. And I think this is powerful, that you can see in this, basically this problem this gravity has. You can see how powerful on the other side this is in its spiritual implication, that if you consider God to be like something, God's power to be something like gravity, that it affects everything, and that the closer you get, the more powerful it will be, the more it will reach to infinity if you look at it on a fundamental level. So scientifically it might be not really sensical or not really makes sense what I'm saying there, but I think in the spiritual that's a sign that, or you can interpret it in this way, that it really shows how powerful our God is, and that everything in us can be changed by him, and that nothing is out of reach for him, and that he's really able to transform us. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there is always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the block. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast, and then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that, and now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.